Hello and welcome to our latest video. In this video, we will be providing an overview of Spaya's general use. Spaya, developed by Iktos, is a retrosynthesis prediction engine. It allows you to input any small organic molecule of your choice, and the algorithm will generate a synthesis plan that can be traced back to widely available commercial starting materials. Upon registering and logging in at Spaya.ai, you'll be greeted by the main page, which looks like this. A free trial version is available, granting temporary access to all the features found in the full version. Please keep in mind that you should avoid entering proprietary or sensitive molecules into the system, as the trial version is a public platform and any information disclosed could be considered public. The user interface of Spaya is very straightforward, featuring a search bar where you can enter any SMILE string, which is a textual representation of a molecule, to initiate a Spaya search. Alternatively, you can use the integrated sketcher tool by clicking on it. This allows you to draw a molecule of interest for Spaya to perform a retrosynthesis search. The sketcher operates similarly to other chemical sketching programs, making it easy to use. Shortcuts and hotkeys are available for a more efficient experience. If you're uncertain about any features or their functionality, simply hover your mouse over the tools to view their purpose and the corresponding shortcut or hotkey. Let's illustrate an example molecule and observe how Spaya conducts retrosynthetic analysis of a compound. On the screen, we have a ligand in complex with the RNA-dependent RNA polymerase enzyme from the dengue fever virus. This ligand is an outcome of a drug discovery project and not readily available to buy off the shelf from any of the commercial providers. So let's see how Spaya performs its retrosynthetic analysis. We will copy its SMILES and paste it into the search bar. Upon clicking the search icon in the search bar or by pressing enter, Spaya will start displaying results for you. These results are arranged in a series of card stacks, as shown here. Each stack is organized on the basis of a similar initial retrosynthetic disconnection highlighted in pink color, which in this case can be an amide bond. Each stack displays a starting from score and the number of steps involved. This represents the Spaya R score and number of steps respectively for the best performing retrosynthesis according to the algorithms. The R score is given between 0 and 1, the higher the score, the greater the synthetic feasibility as determined by Spaya. An R score of 1 indicates a perfect literature match of reactions, building blocks and intermediates. Here, you'll also see the values for the number of unique roots and total number of roots, separated by a /. The number of total roots represents how many retrosynthesis are actually contained within this stack of cards. Upon expanding a stack, it shows all unique roots based on their initial starting materials. Every root highlights where in the target molecule the disconnections take place and the starting materials present in that root. Upon clicking on a root, it is displayed in the form of a retrosynthetic tree, with the target molecule on the top, connected to simpler starting materials through reactions. For each reaction, Spaya will present to you certain references for that reaction. These references come from actual literature examples that are most similar to the ones proposed by Spaya in the retrosynthetic tree. If you want to find more information on any one particular reference, when available, a link will appear here that you can click on and follow. If you are not satisfied with the initial reference, then Spaya proposes multiple references which can be examined. As you're exploring your retrosynthesis tree, it will end in commercially available starting materials indicated by the green basket icon. If you want to see more information on any commercially available starting material, just click on that compound. And you'll be able to see all of the providers who have this compound in their catalog along with any additional information that they might make available in their catalog. These are all commercial partners of Iktos who have uploaded their catalogs to our starting material database. You can see here how much of the compound you can purchase, the price per gram, estimated delivery time, and other generic information like their CAS number, smiles, and purity for this compound. Spaya has advanced search features that lets you customize how the retrosynthesis search is performed, so that you can get results that match your expectations and needs of the project. These search features are available under the Advanced tab in the search bar in Spaya. We will go through each of them individually and explain how they impact the search results. To begin with, we have a SMILE string of the drug valsartan, which is an angiotensin II receptor blocker and is used to treat hypertension and reduce cardiovascular mortality after myocardial infarction. It is always a good idea in practice to start with a Spaya search with no advanced search settings to see how the algorithm performs on your molecule of interest, and to make sure that you're seeing some results. So if you have a molecule that's very challenging to make or outside of the applicability domain of the Spaya algorithms, then adding advanced search features won't find routes that don't show up with the standard search features. But once we have performed a search, we can look at the results as we did before, going through the stacks of cards and the individual cards underneath to see the retrosyntheses. Or we can pull up the Advanced Search tab here and begin making changes to the advanced search criteria. The first advanced search feature here is the maximum number of steps, which limits the algorithm to fetch routes only within the given number of synthetic steps. The default setting here is 15, which means 15 steps to synthesize your target molecule from commercially available starting materials. If the algorithm finds routes longer than that, then it won't show that route. You can increase or decrease this value depending on what you are interested in, and hence, if you are interested in very short retrosyntheses, then you can decrease this value to single digits. If the length of the synthesis isn't as important to you, you can leave this value unchanged or increase it. Next, the maximum price per gram is a filter to limit the acceptable starting materials to only those which cost less than your specified value. Note that with a more stringent requirement on acceptable starting materials, Spaya may take longer to find a retrosynthesis route, or it may produce longer routes with more synthetic steps, or it may not be able to propose a route. All price values are normalized to US dollar per gram based on vendor catalog information. You can also use the Packaging Advanced Search feature to limit the broad classes of starting materials available to Spaya, using any combination of packaging types. When proposing a retrosynthesis, Spaya will be required to find routes which end in molecules present in the allowed databases. The Max Delivery Time Advanced Search feature is present to limit the acceptable starting materials to only those which are expected to arrive faster than your specified cutoff. All delivery times are represented as the expected number of days based on vendor catalog information. One can use the provider's advanced search feature to limit the building block databases Spaya will have access to. When proposing a retrosynthesis, Spaya will be required to find roots which end in commercial molecules present only in the allowed databases. Usually, we recommend deselecting literature, as building blocks obtained solely from it do not usually have a price tag and estimated delivery time. The Avoid Regioselectivity is a feature you can turn on, which forces Spaya to fetch roots without reactions that could have a regioselectivity risk. As an example, let us use these advanced search features on our current molecule. Please note that the more constraints are imposed on the search, the longer Spaya might take to fetch roots. As Spaya completes its search, we will start to see new results here. All of the roots will have less than 3 synthetic steps, the price of starting materials will be less than $50 per gram, and the estimated delivery time will be less than 30 business days. In this case, because we have selected a common drug as our target of interest, it is available very inexpensively from commercial suppliers off the shelf. But, if you are interested in understanding the simpler materials that might be used for the synthesis of the drug, users can initiate another retrosynthesis by clicking on More Roots from here, using the default or advanced search features. Spaya will then start another search, and the most appropriate result can be selected to extend the current route. But as you can see, the advanced search features we have used, namely the maximum number of steps, price per gram and delivery time, haven't had much impact on the overall search results, presumably because our target molecule is a widely available drug. Hence, stringent constraints imposed on these criteria isn't enough. Fortunately, Spaya has even more advanced search features, where the user can specify a preference for certain reactions to be imposed or forbidden. For example, reactions can be specified here so that Spaya can fetch retrosyntheses with at least the specified reactions. As you start typing a name, a drop-down list will appear for you to choose the reaction from. Similarly, Spaya can be told to use only these reactions. Or, with the help of this toggle, to not use these reactions at all. However, these constraints are very strict and one should be careful about using it as Spaya might return very few, or no retrosyntheses at all. Hence, for the purposes of this demo, we will refrain from using these constraints. As you can see, by specifying reactions as constraints, Spaya has yielded a lesser number of routes tailored more to our expectations. All retrosyntheses that have at least one carboxylic ester, plus amine reaction in them will be featured in the search results. Similar to reactions, intermediates or building blocks can be used as constraints to either impose or forbid them or add them as a preference. To do this, simply copy the smiles of the building block and go to the Intermediates tab. Here you can add it as a preference, or impose, or forbid it. Paste the smiles, and then click on the plus icon. Now we can perform this search on top of our previous advanced searches. As you can see, we have fewer routes than the last time as we used the bromobenzyl bromide as a forbidden constraint. Accordingly, none of these routes will feature it, as Spaya fetches only those routes without it. The final advanced feature that needs to be discussed is the ability to specify the first disconnection in the target molecule, which enables Spaya to fetch only those retrosyntheses that start at that point of disconnection. For this, click on the First Disconnection tab and select the bond or the group of atoms by simply clicking on them. We will now perform this search on top of the other advanced search features specified previously. As you can see, Spaya only returns one unique route for this point of disconnection. Finally, Spaya enables users to save a route in PDF format. For this, click on the ribbon icon on the right-hand side of the screen. Assign it a name. And then assign it to a new or an existing project folder. Click Save. The saved route can be accessed by clicking on My Projects, and then on to the project folder. Here, click on the route. Click on the references you wish to save in the PDF file by clicking on the pin icon of the appropriate reference. Please note that this step of pinning references is optional. Click on the three-dotted button. Save the changes. And then select Generate PDF. A link will appear on the screen to download the PDF, which can be visualized in the viewer of choice. As you can see, the earlier pinned references appear as well. If you have any questions regarding Spaya and any of its features, documentation can be accessed by clicking on the Profile button and then on the FAQ. This will take you to the documentation where you can access a number of articles on Spaya and its features. The documentation can be searched by providing keywords, which will fetch you all articles that have the specified keyword. Thank you for watching this video. If you have any questions regarding Spaya, please reach out. We'll be happy to help.